Welcome back everyone to Data Science for Everyone. Today we're going to be looking at TensorFlow Basics Classification. Let's get started. So first off, let's go on import TensorFlow as tf, and then we're also going to grab in NumPy as np. We're also going to import matplotlib.pyplot as plt. And just for you guys, I'm also going to say this is, we're using version, TensorFlow version 2.8 as of today. And we're going to be doing this all on the fashion minced dataset. So this is similar to the numbers minced dataset, but it is utilizing some clothes, shoes, that type of stuff. So we'll be able to have a little bit of fun with it. So let's go on here. There's, I'm just going to call it minced because it's just it's shorter. So tf.keras datasets here, and then it's fashion minced, and we're going to say train. Let's do X train, Y train, and then we'll do here X test, Y test, and these are going to these are all going to basically correspond to some images along with some labels, and we'll take a look at each of these really quickly here. So these train variables, so if we look here at our X train, we look at this again, notice here that they're just like a bunch of zeros and ones, and if we look here at our Y train here, you can notice here that there's like a 9, a 0, a 3, a 5. And so what's happening here is that we have these nice images that are going to be basically a 28 by 28. So we can see that actually by looking at this X train.shape. We take a look here, and so there's 60,000 images in this data set, or at least in the training set, and we have each of these are going to be 28 by 28. Now we have in here, if we look at Y train, and if I do something like maybe set on Y train, notice that we have basically 0 to 9 on our labels. Now these labels are going to correspond to the classes of clothing that they represent. And so we can go on here and do class name in here, and let me type these out real quick, and I will bring the recording back on. So we can see here that our class names come through several different aspects. Here we have t-shirt, top, trousers, or so long pants, a pullover, dress, coat, sandal, shirt, sneaker, bag, and ankle boot. And so each of these are going to, again, have this 28 by 28 shape. This 28 by 28 shape here, okay? And again, we need to make sure that we have the same length in here. So this is here 60. So let's also go on and say our Y train.shape for now. And again, you will see here that they are basically a single vector of 60,000 observations. So let's go on then and take a look. Well, I guess maybe we can also do this just to make sure that we're not crazy here. So let's do also our X test.shape and our Y test.shape. Make sure that they're at the same size as well. Okay, they are, and again, notice they are 28 by 28. So again, if we do anything here, we need to make sure to create up functions for everything as we go along, and so we'll do that. So now let's start a little bit of the pre-processing. So let's go on to do something like plt.figure here, and we'll do fig size. Let's do a 10 by 10. Let's do plt.im show here, and we'll do x train by, I don't know, 42. And then we'll do plt dot grid false, and then we'll do plt dot show. Take a look here. And notice here that we have what looks like, I would guess that this would be a ankle boot, most likely. So again, look, it's a little bit tall, and we can look at maybe another one here as well. And this is maybe a little big, so let's do, I don't know, 6 by 6. And we'll change this to, let me just delete that and do 4 here. Maybe a pullover. Let's do a t-shirt of some sort. Whoops, not J. Let's do 0 in here, and we can see if there's another one in here. And notice that looks like some sort of shoe, maybe again, maybe another ankle boot. So let's go on then, and we need to actually scale these images, okay? Because they are, again, 28 by 28. Now, we need to scale these again to be between 0 and 1, okay, before feeding them into a neural network. Now, to do this, we need to divide the values by 255. Now, we're doing this because, again, these are technically in black and white, okay? They're black and white images, and so they're going to be on some sort of grayscale. So we need to do that for both the training and the test sets. So x train is equal to x train divided by 255. And again, we'll make sure here that to use a decimal here because, again, to make sure that they're going to be floating point. X test here will be x test divided by 255.0. And then let's go on, and to make sure that everything's going to be in the correct format, we're going to display some images. Maybe we'll do like the first, I don't know, let's just do the first maybe the first 10 images or so, or maybe we can do a little bit more, just to see what we want and make sure that everything, again, looks nice. So we'll do plt dot figure, and again, this time we'll do a 10 by 10 because I know it's going to be pretty big. Whoops. Plt dot figure fig size is equal to 10 by 10. And then we'll do for I in range of 10. Oops, using too much JavaScript recently. Plt.subplot 5 by 5 plus I. Here, again, we need this I in there, this plus I, so that it's in the right order. And then we'll do also plt.x ticks. Here, we want to actually just turn them off. So we'll do that. And then we'll do plt.y ticks. And again, we're just going to put in an empty list there to kind of turn them off. And then we will do plt.grid. Again, since these are pictures, we also want to set this to false. And then we'll do plt.im show x train of I cmap is equal to plt.cmap of binary. And then we'll do plt.x label, and this will be our class name of what? Train x train, no, y train here. Y train of I. And then we'll do plt.show. It doesn't like this. What did I set as a class? Names, class names. Oh, okay, whoops. All right, and an illegal 5 by 5. let's actually put this up. Oh, that's silly of me. We'll do this up to 25 because again here it's going to be this here I said 5 by 5, so 5 multiplied by 5 is going to be 25 squared in there. So let's run that through. Oops, and it's 5 by 5, 5 by 5, and then it's I plus 1 because I'm being silly here. And again, we can see that we have quite a few in here. So, and you know what, let's actually go on and do those 10. Because again, let's do 5 by 2 by 5. Oh, and then we'll have a little bit of a gap in there, but that's okay. So notice here again that we have our ankle boot. So that first one was an ankle boot. We have t-shirts, t-shirt. I don't know why that would be a t-shirt, but okay. We have a dress, another t-shirt, a pullover, a sneaker, pullover, sandal, and sandal. So these are a great way to kind of visualize what we're wanting to look at. So the next thing that we're going to want to do here is to set up and build up a model with our neural network layers. So we're going to go on and use a sequential model first, and this is the basic building blocks for a neural network layer. And so they're going to actually extract up the representations from the data that's fed into them, and it's hopefully going to give us a meaningful interpretation of the problem at hand. So let's do a model is equal to tf.keras.sequential here, and we'll put in, oops, and we'll do something like tf.keras.layers.flatten, and our input shape here is going to be our 28 by 28. And we'll do tf.keras.layers.dense. Here is 128. Activation here. Oops. Activation is going to be our RELU. And then keras.layers.dense of 10. And again, we want to put them out by what the number of labels that we're having put out. So again, most of the time we're going to be having these nice dense layers that are going to learn for our training set. Now this first layer in here, this flatten, okay, transforms the format of our images from a 2D array of this 28 by 28 into a one-dimensional array. Okay, so that would be like 28 by 28, which is 784, okay, pixels. Now, this is basically going to be, think about it as unstacking the rows and lining them all up. Now, this dense layer in here, okay, is basically, again, these two, I guess, dense layers here are, these are densely connected, okay, and these neural network layers, this first layer in here has 128 nodes, okay, so that's what this 128 is for. And here in the second one, again, is going to return the logits of our 10. Okay, so that's for our 10 classes 0 through 9. So the next thing that we would want to do is compile the model. So I'm going to have it ran this, so let me go in and run it. And when we compile our model, model.compile here, we are going to need a couple things in here. Okay, so we need a loss function, an optimizer, and our metric. So first off, let's go on and put in the optimizer. And here we're going to use Atom. And again, in subsequent videos, we'll go through and we'll talk about each of these in turn. Our loss function is going to be tf.keras.losses. And then here we're going to use the sparse categorical cross entropy from logits is true. And then we'll also add in our metrics in here, and we want an accuracy metric. Okay, we'll run that, let it compile. So now to train the model, we're going to require a couple steps here, okay? We need to feed in our data to the model, and basically we're going to have our X train and our Y train. Then the model is going to associate with each of the labels, and then we're going to move on and make predictions, and then finally we're going to verify those predictions. So first off, we need to feed in the model. So that would be model.fit X train, Y train, and we'll have in here, we'll just do 10 epochs. Run this, and again, this will take a minute, so I will stop and start here in a second. Okay, so this model is done. You can see here that it ran all 10 epochs. Now the next thing that we want to do is to go on and, well, and look here, if we actually take a bit of a look. Again, here it says that this last one, it's each time it's kind of calculating up its accuracy and its loss function, okay? So the model and loss are going to display, this last model is about 91% accurate with the training data. So let's go on and actually evaluate up that accuracy. So we'll do test loss with test accuracy. And we'll have our model.evaluate. Here our X test, or Y test. We'll say verbose 2. And let's also go on and say print in here. Let's have an F string test accuracy of test accuracy. Whoops. So, and we see here that we have around an 88% test accuracy for the data. Now, this is a little less accurate than when we were using the training set. And again, this may be, well, the question we always want to ask is, again, is it overfit? Okay. And again, sometimes maybe it's just basically memorizing some things, and it's gonna we need to take care of some noise in there, and so maybe we want to dig into it a little bit. So again, you want to maybe optimize your model. But again, in this instance, we're just trying to give you guys an idea of what's going on. Finally, we want to go on and make some predictions with the model. So first, we want some probabilities of the model. So tf.keras.sequential here, and we take our a list of the model, and here we can use the tf.keras.layers.softmax in here to get a hold of those probabilities. And then we can also make some predictions with those probabilities.predict in here with our X test. And then we can take a look. So for example, we can do pred of 1 in here. And again, it has the likelihood of each of these of the 10 predictors. Now, this doesn't necessarily help us a whole lot because again, we're saying, oh, which one does this actually apply to? So we can actually use the MP argmax in here of our argmax of our predictions on 1. You can run this and see that it corresponds to 2. Okay, that is our that would be what it would respond to, and 2 was what? 0, 1, 2. It was a pullover. Okay, so that may be good. Again, we know, let me go back up here, and we know, so for example, this first one here is definitely an ankle boot as well. So let's also just double check with that. So if we do prediction of 0. Notice that gives us 9. Sandal. So we'll have to take a look and see which of those work here. But also, let's go on and maybe make a couple predictions for each of these models. So this is actually going to be a little bit more fun, I believe. So we want to actually put out a graph that looks at the 10 classes, and it's going to take a look and actually help us verify our predictions. Because again, here you notice maybe I made a mistake in what I was looking up here, and we need an actual visual on that. And actually, again, probably it's because I was looking at the training data here and not the test data. So let's go on and create up a plot. So let's do def plot of an image. Here it'll take an I, it'll take a prediction array, it'll take the label, and this, let's call this the true label, and then it'll take in an image itself. So we'll say true label in here, image is equal to our true label of I with our image of I. Then we'll say plt dot grid of false. And again, here we're basically redoing the plot that we had up here. Okay, so that it'll look nice and clean for us. And again, we'll say plt.xticks is an empty array. plt.yticks, again, is going to be an empty array. Then we'll say plt.imShow, and we'll take in the image. It'll do a CMAP here of plt.cm.binary, because again, we want it to be black and white. And then we'll have our predict label in here. It will be mp.argmax of the prediction array. Then we want to say if the prediction label is equal to the true label, then we'll say the color is green for go, else we'll say the color is red for stop. And then we also want to do plt.xLabel here, and we have a nice f string, and we want what in here are class names with the predicted label. Then we want in here the max prediction array. So we'll do round 100 multiplied by np max of the prediction array. And that would actually be a percent. And then we want what here? We have this, and we'll do one more here, and we want our class name, class names, true label. I think that'll do. And then we'll see here in a minute if we need any more information. And let's do plot value array, I with our prediction of our array, our true label. Then we want our true label equal to our true label of I. And then again, we want this. And then we want to say something like, you know what, let's actually give this x, we want a range of 10, and we'll set this to, yeah, nothing. And then we'll say this plot here, so p is equal to plt bar range of 10. For our predictions, we need a prediction array. Then we need, I think we'll leave that blank for now. We'll do plt.y limit, here 0 to 1. And then we'll do a prediction label is equal to np.argmax of our prediction array. P of our prediction label dot set color of red, and then P of true label dot set color of green. We should be good to go. So let's actually go on and give this a try. So if we do I is equal to 0, we have plt.figure fig size. Here is going to be, let's say, a 6 by 3. And we'll do plt.subplot 1, 2, 1. Plot of our image, I, prediction of I, Y train, or Y test, sorry. Y test, X test. Then we'll do plt.subplot 1, 2, 2. Then we want plt plot value array I, prediction of I, Y test, plt.show. Let's see if we got everything right. Oops. We did image instead of img. There we go. And so again, here we have, notice we have this green as definitely the prediction. Now notice here we have a small blip here, and it should be somewhere we need to change the coloration in here. Let me think here for a second. This bar, maybe you guys are probably screaming at me about where I messed up on it, but that's okay. At least for right now, I'm just going to leave it. We won't go back to it. Let's go on and do another one that I happen to know is wrong, so that we can get this red coloration. So this green works. So let's go on and say I is equal to 12. And I'm going to go on and copy that. Paste that there. Run. Whoop. Oh, and it still turned it. It did not. I'll have to find one that's wrong. It did a good prediction on this one. So let's see here. Maybe if we run this in a nice loop, we may be able to find one. So let's do something like number of rows is equal to 5. Number of columns is equal to 3. Number of images is equal to the number rows multiplied by the number of columns. And again, I would suggest that for you guys, I would make these into a function and maybe even into your own class so that you can have everything together. It'll make your life a lot easier, make your own little project template, as it were. So let's go do plt.figure of our fig size here. And again, this is 2 by 2 by the number of columns 2 multiplied by the number of rows. And again, we do this because we have 1 and 2 here. So for I in range of the number of images, then we'll say plt dot subplot number of rows 2 multiplied by the number of columns 2 multiplied by the number of rows. All right. Nope. I was just looking the wrong one. And this is 2 multiplied by I plus 1. Number of rows, number of columns, 2I plus that, and we'll do plot our image with I, our predictions of I, our Y labels, not Y labels, Y test, X test. Our subplot, again, will be our number of rows, 2 multiplied by the number of columns, 2 multiplied by I plus 2, to move that down a little bit more. And then we will do plot value of our array, I, our predictions of I, and our Y test here. And then we want this to be a nice tight fit. And then we also want to show everything. Okay, and it seems here that everything was a good prediction. I would like to see, let me pause for a second, and I will find one that is wrong, and so that we can actually see that. Okay, so all I did was add and make this a nice 5x5 so that we can count up a little bit more. And we can see here that we have this pullover here that was misinterpreted as a coat. And we also have this sandal, which was misinterpreted as an ankle boot. So at least we know that this is working here. And we also notice that there are some of these that are okay, but again, we have some that are kind of standing out. Now we could do a couple more tests in here and kind of optimizing this, but again, this is just kind of something to play around with. Now, the final thing that we would like to do is actually run and use our model. So if we just say something like image is equal to some x test here of 1, and we do print image shape here, we see that we have a nice 28 by 28. So let's go on and take this and make sure that it's only, let's expand the dimensions out. So we'll do mp.expand dimensions of the image 0, and then let's take a look here. We'll do print image shape, and notice now it's in this 1 by 28 by 28, so that's in a proper format for us to use for our prediction modeling. Again, we have to do this so that it'll actually run. And if we do something like pred 1 here, we can do our probability model here dot predict of the image, and I think I did it was just prob run, and then we can say print of our pred 1 here, and we have our items. And again, we can go on and use our pre-made plot. So plot value of the array, we can do 1. Our prediction 1 of 0, our Y test, and then we can say plt.show. And notice here we have 2. All right, so let's make sure, let's change this up just a little bit so that it actually looks good for us. And we'll say something like plt.xticks, range of 10, class names, rotation here is 45 degrees. So notice here that now it is a pullover. And again, if we go through and we actually plotted the image for this, then we would also notice that it is a pullover. So if you guys like this video, please comment, subscribe, and hit that like button. And I will see you guys next time. Bye-bye.